Yes, so let's move on towards our lecture number 20 of physics optional for UPSC CSE. And someone was asking that what is the difference between state PCS and UPSC. So very easy answer in one sentence. If UPSC is, if UPSC is suppose 2000 rupee note, suppose UPSC is 2000 rupee note, okay, 2000 rupee note. So state PCS, it is rupees 2, it is 2 rupees. This so much is the difference between UPSC and state PCS. If UPSC is rupees 2000, then state PCS is 2 rupees. This is how I can describe the difference between UPSC and state PCS. Okay. So the two eigen functions. Let us write one more question. Okay, such questions are repeatedly asked in UPSC. The two the two eigen functions. The two eigen functions of a particle. The two eigen functions of a particle moving in one dimensional potential. Potential are the two eigenfunctions of a particle moving in one dimensional potential are psi 1 sorry psi 1 x is equal to e to the power minus x square over 2 and psi 2 x is equal to 1 plus alpha x square, okay, e to the power minus x square by 2, okay. Find the value of alpha such that more by the way I would like to tell you one thing, that I have come back on social media, okay. I have come back. I have come back on social media because my target was completed. Why I have come back on social media? Because my target was completed. Because my target was completed. And how was my target completed? By not looking at the mobile for 2 days. On 5th and 6th of September, on 4th and 5th of September, I didn't look at the mobile. Okay. From 4th September 8 p.m. onwards. Okay. From 4th September 8 p.m. onwards till 6th September 6th September 12 p.m. Okay. So for this much of time, I didn't look at the mobile completely. I just turned off the notification of WhatsApp and Telegram and your Instagram also. I turned off the notification for this much of time so that I can complete my target. And what was my target? My target was to prepare for my upcoming maths optional course. Okay, this was my target. And I was getting distracted because of social media, so I just quit it for this much of time. And after I quit it for this much of time, I was able to complete my target. And I had decided that before 7 September morning I will complete my target. But but fortunately it was completed one day before. Okay, so such things you will also have to do while preparing for UPSC. If sometime you need such things, then you should do such things, obviously. Okay. If someone of you might feel distracted because of social media, so you can obviously do this always. Okay, so if the two eigenfunctions are given like this, find the value of alpha. So the question says that find the, so if someone of you is feeling very uncomfortable, okay, one student was there, his name is what is his name, I am forgetting his name. Yes, Surendra Raj Purohit is his name, okay. Surendra Raj Purohit. He was getting very much he was feeling very dull. Why? Because I was not there on social media. He was saying that I am feeling underconfident. I get confidence after talking to you. I am feeling underconfident. Okay, confident. So, beta, stand on your feet, beta. Stand on your feet. Okay, stand on your feet. Don't worry. I am always there with you, but I can only give you support. Okay, I can only give you support. Ultimately, you have to yourself stand on your own feet. Okay. So, find the value of alpha such that psi 2x is orthogonal. Okay, is orthogonal. Psi 2x is orthogonal to psi 1x. And I was not distracted because of my students messages. Okay, I was not distracted because of my students messages. I love my students messages, but the problem is I was getting distracted because of some other persons. Okay, some other persons were there for from my college, and some persons were there from my old friends. Okay, some of my very old friends, those friends were messaging me. Okay, so that's why I was getting distracted. If only students were there na, I won't have been distracted too much, that much. Okay, because students love me, so they always help me to even I feel motivated because of my students. So my students are my motivation. So no, there is no harm in students messaging me or sharing their problems. But the problem is some of my old friends, some of my faltu type of friends, those friends were messaging me. So that's why I had quit the social media for 2 days, so that I can complete the maths optional slides, the course of which is starting from 14th of September this month. Okay, so that's why I was busy. Okay, so I have messaged right now I have messaged in 1 hour I completed all the chats of my students. Okay, I finished all the chats of my students, and I replied to each and every students in 1 hour. Okay, today I saw the chat and replied to each and every student. For 1 hour I did the same thing. Okay, so if two eigenfunctions are there, find the value of alpha such that psi 2x, okay, is orthogonal to psi 1x. Okay, so how to solve this question? You know this very well, that over here limits are not given. What is there? Limits given hai kya? Are limits given? Limits not given. So as limits are not given, consider minus infinity to plus infinity. Okay, so limits worry is over. Limits worry is over. So minus infinity to plus infinity. Now what is this is orthogonal. It is asking about orthogonality. So for orthogonality we have the condition of orthogonality. So psi 1 of x, let us write once again over here, that psi 1 of x is given to us like this, and psi 2 of x is given to us like this. Okay, 1 plus alpha x square e to the power minus x square over 2. Okay, so uh, for psi 1 and psi 2 to be orthogonal, for psi 1 and psi 2 to be orthogonal, we have the condition minus infinity to infinity psi 1 star x, okay, psi2 star, not psi2 star, psi2 only, okay, dx is equal to 0. I had told you already this orthogonality condition in the previous classes. Okay, we take the conjugate of one function and multiply it with the other function. Okay, so conjugate of psi1 we are taking. You could also have done, this is also correct. What thing is correct? If you take the conjugate of this, okay, instead of taking conjugate of psi1, if you take conjugate of psi2, if you take conjugate of psi2 and multiply it by psi1, that is, if you write the equation like this also, it is correct. Minus infinity to infinity psi2 x, okay, psi2 has a star and psi1 remains normal. This is also correct. Both of them are correct. Okay, so this is the condition of orthogonality. Now I will solve using this. Okay, I will solve using this. So let us solve. Minus infinity to infinity. Now tell me one thing. Do you have iota term present over here? Do you have any iota term present over here? No, you don't have any iota term. So simply the conjugate is going to be the same function as the real function. Okay, there is no imaginary term, there is no iota term, these are real functions. So the conjugate of a real function is the that function itself. So psi1 star, psi1 star will be written, psi1 star will be written like this. Okay, so psi1 star will be written like this, and psi1 star, when it is written like this, you also have your psi2 star. Okay, so psi2 star, how will it be written? Your psi2 star will be written like 1 plus alpha x square, not psi2 star, psi2 only. Okay, minus x square by 2. I simply substituted the values, simply this value and this value I substituted over here. Okay, so there is nothing rocket science in it. Okay, and this is the thing. And why is it d tau is not coming, dx is coming? And why instead of triple integral, single integral is coming? Instead of volume integral, line integral is coming. The reason is that, reason is very simple. It is one dimensional, only x component is there, as is visible from the expression given to us. If it would have been in terms of r, if suppose it would have been in terms of r, then we would have applied the volume integral condition. But since it is in terms of x, so it is one dimensional, and we have to apply the one dimensional formula for it. Okay, so from here it is very clear. So from here it is very clear that minus infinity to infinity e to the power minus x square, okay, 1 plus alpha x square dx is equal to 0. Okay, this is you have simply multiplied this by this. When you multiply these two, powers will be added. By laws of indices, powers will be added. So powers I have added over here, and after the powers were added, this is the thing which you got. And now you will expand the bracket. Now you will expand the bracket. So after expanding the bracket, what will you get? E to the power minus x square dx you will get. Okay, plus alpha will come out of the integral, minus infinity to infinity e to the power minus x square dx is equal to 0. Right, so this is the thing which you get. Now we have already learnt the formula, ready-made formula. I had already told you to mug up. The ready-made formula for this, and the ready-made formula for this. I had already asked you to mug up the ready-made formula for these two expressions. Okay, I had already asked you to mug up the ready-made formula for these two expressions. So what is the ready-made formula we have? The ready-made formula which we have is minus infinity to infinity e to the power minus ax square dx comes out to be equal to square root of pi by a, which has already been covered in the previous lectures. I had asked you to mug up this. Now compare this expression. I will mark it with white. Okay, compare this expression in the white box. Consider this expression in the white box and compare it with this. Okay, compare it with this. Clearly your a value comes out to be equal to 1. Okay, your a value is equal to 1. So what will that integral turn into? That integral will clearly turn into root pi. So we have root pi plus alpha integration minus infinity to infinity, okay, x square e to the power minus x square dx, okay, is equal to 0. This has come out, okay. Now you will basically see this expression. You will basically see this expression. Now one more ready-made formula is there, which I have already told you to mug up in the previous lectures. The ready-made formula looks something like this. The ready-made formula looks something like this, that e to the power minus a x square x to the power 2n dx, okay, is equal to 1 into 3, okay, into 5, okay, and so on and so forth up to 2n minus 1, right, divided by 2 to the power n, okay. So square root of pi over a to the power 2n plus 1, okay, right. Now substitute the value of a equal to 1 over here, okay. Now compare these two, compare this with this green expression, this white expression with this green expression. Just compare and tell me one thing clearly. A is equal to 1 over here clearly, and n is equal to also 1 over here, right. So after putting n is equal to 1 over here, after I put n equal to 1 over here, 2 into 1 minus 1, after I put n equal to 1 over here, 2 into 1 minus 1 becomes 1. So all these are gone and only I am left with 1, okay. So 2 to the power n, when n equal to 1, so it will become 2. And over here a is also 1. So 1 to the power anything is 1. So this term is also gone, okay. So I am left with 1 by 2 root pi, right. I am left with 1 by 2 root pi. So the expression turns into root pi plus alpha 1 by 2 root pi. The expression becomes like that, okay, is equal to 0. Now I know this very well, that I will divide both side by root pi. So after I divide both side by root pi, I simply get this thing, and after I get this thing, I can clearly write minus 1. That implies alpha is equal to minus 2, okay. So value of alpha has come out to be equal to minus 2, and this is what had been asked. This is what has been asked. You yourself look over here. You yourself look over here. Find the value of alpha has been asked, right. Find the value of alpha has been asked, so that these two functions are orthogonal. Find the value of alpha so that these two functions are orthogonal. That is what was asked, and clearly you can see this thing, that alpha equal to minus 2 has come over here, and our value of alpha, our value of alpha has been clearly found out. So your question can be solved like this. So your question was solved, okay. So hopefully you enjoyed the session, and our lecture number 20 is over with this. Our lecture number 20 is over with this. Now lecture number 21 we will move on in the next class, and most probably lecture number 21 will come all today only, okay, because I have to really run very fast, so that the syllabus is completed on time, okay. So thank you very much. Join Telegram if you haven't joined it yet.